Alright, welcome back. Math 1720. We are in Chapter 7, looking at Section 3. We just completed the ambiguous cases for the law of sines. Now we're going into the law of cosines. Alright, I'm not going to go through the derivation of law of cosines, but I want to get into the application piece for us and how we really apply those. So if we have triangles that are side angle side and side 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 triangles, we can apply the law of cosines. Alright, and then we'll talk a little bit about Heron's formula for the area of a triangle. Okay, and I'm not going to go through the derivation of Heron's formula, but we'll be able to apply Heron's formula for tests and homeworks and things like that. Alright, so when we talk about the law of cosines, okay, we have a side length restriction. So in any triangle, the sum of the lengths of any two sides must be greater than the length of the remaining side. Alright, so there's just it's a quick check. Alright, so that you can, add, alright, A and B, alright, they gotta be greater than whatever that remaining side is. Okay, even if that side's the long one, right? So we can take like the two short sides, it's gotta be greater than the long ones, okay? Or the long one when we go through that. So I'm not going to get into the derivation, so I'm going to kind of skip ahead here. The notes are online if you want to look at them and go through where they come from. But what I really want you to write down here is the law of cosines. There's three versions for the law of cosines. Alright, it just depends on which side length that you're solving for. So it's very important when you do your assignments to draw your triangles out and clearly label what A, B, and C are to do this. So here are the three versions. You can write those down. I'm not going to write them all off. But just note, if you actually wanted to solve for A, you would have to square root the entire function on the right-hand side. If you want to solve for B, you'd have to square root everything on the right-hand side. Same with C. So just note that it's kind of like doing the Pythagorean theorem, right? If we had to find the missing hypotenuse or find the missing leg, all right, that's how we're going to solve for it. And the Pythagorean theorem does technically come from the law of cosines. And we're going to see that. So if you substitute in an angle of 90 degrees, all right, cosine of 90 is 0. So therefore you are literally left with the Pythagorean theorem, c squared equals a squared plus b squared. So that's where it comes from. All right, when you do those calculations. So you've spent many calculations doing the Pythagorean theorem, but there's where it can be derived from. So let's take a look at an example here of applying the law of cosines. Alright, so we're using a side angle side type of triangle here. We're given two side lengths and we're given the angle between them. Okay, so let's read through it. Make sure you guys always draw the triangles out. I would like you to draw them for every homework assignment that requires it. It will really make sense, especially when you get more of a paragraph type form. We're crossing a river or we're traveling this direction. It really makes sense. Okay, and guys, this is important because we're going to get into vectors soon and we're going to need to be able to apply the law of sines and the law of cosines, solving vectors and those sort of things. Okay, so we have a surveyor that wishes to find the distance between two inaccessible points A and B on opposite sides of a lake while standing at point C. Okay, she finds that B is 259 meters, A is 423 meters, and angle ACB, remember the letter is the middle piece, that's where the angle is, and angle ACB is 132 degrees 40 minutes. We want to find the distance C. This is where you have to look at your law of cosines. So you should probably have like a little sheet going on for this chapter like we did last chapter. Last chapter you had all the identities, or I'm sorry, in chapter 5 you had all the identities and everything going. Chapter 6 was just kind of showing how we did the inverse functions. This one, you might want a little list going on, so write down the law of sines, the two different forms of the law of sines. Write down the three different forms of the law of cosine. Alright, and then let's see what applies here. We're looking for little c, we have little a, we have little b, and we have big C. So we are able to apply the law of cosines here. Alright, this is the form that we're going to use. The c squared equals a squared plus b squared. Okay, and it should not say equal right there. That is a typo. That should say minus 2ab cosine c. That equal sign is a typo. next to the 2ab. It should say a minus. So when you write this down, c squared equals a squared plus b squared is not equal to, it should be minus 2ab cosine c. Alright, then we substitute in our given values. So I am sorry that it's still carrying that equal sign through instead of the minus. Somehow I used an older equation editor and it's not allowing me to change it. I gotta retype it all in. But so I'll go back and fix that for you guys online. But if we substitute our values, all right, you don't have to like pay attention. There's not really going to be unit changes with these sort of things. All right, so we're going to plug it in. All right, 423 squared plus 259 squared minus 2 times 423 times 259 cosine of 132 degrees 40 minutes. You know, make sure that you're putting this in your calculator correctly. Sometimes, you know, order of operations. I tend to put one parentheses in front of the minus so that it doesn't screw that up. When you put all that in your calculator and hit enter, you should get approximately 394,000-ish and 510 or whatever it's up there. Okay, then we have to actually find the value of c, so we square root both sides. So you should get 628. So make sure that roll through this with your calculator, making sure that you're substituting in the values into your calculator correctly and actually getting this value. Sometimes, you know, just to be safe, I use the store command, so I can actually store the value of A into A, store the value of B into B, and store the value of C into C, and then I can just type in the equation as I see it, and it'll calculate everything because I've stored the correct values in. If you don't understand what I'm talking about, I'll show you in class, those of you guys that are in class. If not, don't worry about it. I don't want to confuse you if you don't know how to use the store value command in your calculator. Alright, so the distance between the 2 points that she calculated is 628 meters. Alright, let's do another example here. Side angle side. Alright, draw the triangle so you can literally see what's going on. Make sure we're drawing them correctly. Little a is across from big A, little b is across from big B, and little c is across from big C. So we should see here that we have side angle side, we have two sides and the angle between them, and we can apply the law of cosines because we are looking for little a, we have little b, little c, and big A. Literally choosing the right law of cosines, that's the first step that you should write down when you do all these. So do exactly as I'm doing here. We got a squared equals b squared plus c squared minus 2bc cosine of a. Make sure that you're always choosing, all right, the right function. Based on the letters that you have, it really makes it easy for you, and it makes it much more convenient when you do it that way. Substitute in the values that you have, so we're going to have 12.9 squared plus 15.4 squared minus 2 times 12.9 times 15.4 times cosine of 42.3. I know this is a little late in the game. Make sure that you have your calculator in degree mode where you're not getting the right values for these. Degree mode, very important when we're doing these problems. You should approximately get about 10.47 for A. You're going to get that big value, and don't forget I didn't show the step on here. You need to square root your answer. Don't square root the 10.47. Square root whatever you get for A squared. Okay, so whenever you type all that into your calculator and hit enter, square root it at the end, and when you get the square root of that answer, it should give you 10.47. Make sure you're putting this in the calculator, getting the same values I'm getting. If you're not, email me. We can Zoom or something, or I'll ask questions in class and we can work through that. Okay? So, here what we have to check though. Alright, angle B is less than angle C. Since it's opposite, the shorter the two sides B and C, therefore B cannot be an obtuse angle. It's really going to kind of be the restrictions on that. Okay, so essentially we would have to note that B needs to be, like, it cannot be larger than C. C has to be the largest angle, right? The largest angle has to be across from the largest side. Smallest angle has to be across from the smaller side. Alright, so we know that A has to be the smallest angle, alright, at 42.3. So we can use the law of sines to find the other angle here, just to verify and check everything. So sometimes we can use the law of cosines to find an angle. If we have the side lengths, we can. It's a little bit more work. To solve for the angle using law of cosines, we got a little bit more algebra to do. but we'll be able to do that as well. But we can apply the law of sines here. I'm not going to get too much detail into doing the law of sines because we did that the last 2 lectures. So you should know how to apply the law of sines here. So since we're looking for an angle, we're going to use the law of sines version where the angles are on top. So we're going to go sine of A over little a equals sine of B over little b. Substitute in our given values and get our angle measurement. Remember, you have 12.9 times sine of 42.3 all divided by 10.47. You hit enter, you're going to get some sort of decimal answer. Remember, you have to hit second sine. You have to take the inverse of that ratio to get the angle. So make sure that you take second sine of that value that you calculate to get 56 degrees. So make sure that you're checking in your calculator that you're getting the values here, and if you're not, you need to let me know so that I can make sure that you're doing that correctly. Okay, so that gives us the second angle, which is 56 degrees, and then we can find the third angle, all right, because we're solving the triangle. You're taking 180 minus the given 42.3 minus the 56 that we just calculated, and the third angle is indeed 81.7 degrees. So this triangle is true, right? 81.7 is the largest angle, and it is across from the largest side. The smallest angle is 42.3. It's across from the smallest side length that we calculated, which was 10.47. All right, and B is in the middle. So this triangle is true, and we were able to calculate everything for it. Okay, so in this scenario, if we had used the law of sines to find C rather than B, we would not have known whether C was equal to 81.7 or its supplement 98.3. Remember, when if we pick a certain angle here, it might have 2 solutions. That's what we did with law of sines. So be careful with what you choose. Remember, if we chose the side-side angle scenario, which is what it's talking about here, there could have been 2 possible angles that you could have found for this. So be careful of that when you do that and you use the law of sines. Alright, so let's apply the law of cosines to a side-side-side triangle. So this is where we have to use the law of cosines, manipulate it algebraically to find the specific angle. Okay, so we'll use the law of cosines here because we're given 3 sides. This is something you can only use the law of cosines here. You cannot use the law of sines. So understand, on a test, if I give you a side-side-side triangle, you have to decipher, am I using the law of sines here or am I using the law of cosines? If I give you side-side-side, you know that you need to use law of cosines. Only way for you to find it. Okay, so we can choose whatever angle we want. Alright, so let's choose to find angle C first. So I have to rewrite the law of cosines so that I can find angle C. In order to find angle C, I have to find cosine of angle C first and then take the inverse of it. So I'm going to take the equation here, c squared equals a squared plus b squared minus 2ab cosine C. I'm going to solve that for cosine of C first. So I'm going to subtract a squared from both sides, I'm going to subtract b squared from both sides, and I'm going to divide by negative 2ab. Just basic algebra skills that we have to go through to solve that. Alright, so to find cosine of C, it's going to be a squared plus b squared minus c squared all over 2ab. Okay? Remember that when we divided by that negative 2, it changed all the signs on everything. Alright, so it changed the sign on a squared, changed the sign on b squared, changed the sign on the c squared. So that's how the signs changed. Okay? So now, whatever value you get for a squared plus b squared minus c squared all over 2ab, when you take cosine inverse of that value, you'll get angle C. So we got to make sure that we're really paying attention to do that. So now we solve for cosine of C, all right, by substituting in all the given values for this, so all the side lengths that were given. All right, we're going to get an approximate value here. That approximate value is negative 0.34194. Now, does that value work? Is it between negative 1 and 1? Yes, because that's what cosine can have, right? So we have to be able to take cosine inverse of that value. So in your calculator, second cosine, and then in the parentheses, you're going to go negative 0.3410942. Hit enter. You should approximately get 109.9 degrees. If you don't, make sure your calculator's in degree mode. You might have gotten something in radians instead. All right, but there's how we use the law of cosines to find an angle, all right, instead of a side length. So we're still going to find the other side lengths, all right, but instead of using the law of cosines again, or not the other side lengths, the other angles, we're going to use the law of sines here to finish out the triangle to find the other missing angle, and then once we know that missing angle, we're just going to subtract them both from 180 to solve. So we're going to use the law of sines to find angle B. So remember, choosing the law of sines with the angles on top. You know what little c is, you know what little b is. We just calculated big C, so we can substitute in. Okay, we're going to multiply both sides by 15.9 in our calculator. We're going to get an approximate decimal answer, and then you're going to have to take sine inverse of that value in order to get the 45.1. All right, so once again, take 15.9 sine of 109.9, hit enter in your calculator, then divide by 21.1, hit enter, and then you're going to do second sine, so sine inverse of that value, and then hit enter. You should get approximately 45 degrees or so when you substitute that in. Okay, so now to find the measure of the other angle, like I said, we're going to take 180 minus b, which is 45.1, which we calculated, minus c, which is 109.9, which we calculated, and we get 25 degrees. Remembering that all the angles in a triangle have to add up to 180 degrees. All right, so where does this come in, to real life? All right, so, designing a roof truss. If you don't know what that is, all right, before they put the roof on your house, they connect a bunch of trusses together, right, and then they lay the plywood down, and then they put the shingles across and that sort of thing. So they have to design everything so that the angles are correct. So like back west, they design it more for snow to fall off. So if you have a home in the mountains, you might have like an A-frame type house, all right? So your house looks like a giant A or things like that, or up in Alaska, they do the same thing, so that the snow doesn't build up on the roof and the roof collapses. All right, if you don't have enough pitch to your house or enough angle, all right, the snow won't slide off. It'll sit there, and it can actually, the snow adds up. I know you don't think it's heavy, but when it gets heavy and wet and slushy and melts during the day and turns to ice at night, it actually becomes heavy and can impact things. So very important that designing a roof, you don't think about it, but it comes into a lot of play. Places that you have a lot of rain, you don't want a flat roof. You want the rain to be able to run off. Okay, same kind of concept. All right, so designing a roof truss, we're given side, side, side. All right, so we need to find angle B to the nearest degree for the truss shown in the figure. So since we want to find angle B, we're going to choose the function that involves angle B. So that would be the one with little a, little b, little c, and cosine of big B. So we're going to apply law of cosines here. Law of cosines is the only thing that we can apply here. You could not apply law of sines to this problem because it is side, side, side. All right, so solving for cosine B gives us a squared plus c squared minus b squared all over 2ac. That's just doing the algebra, getting cosine B by itself. Substituting in the given values, all right, that we have, substitute in little a, little b, little c, all right, and do our calculations. You're going to get a decimal answer. You're going to have to go second cosine, because you're doing cosine inverse of that decimal answer, hitting enter, and you should get approximately 33 degrees. So make sure that you are substituting in those things correctly. Make sure try this one at home, make sure your calculator matches what I have here for you. Alright, so let's go over all the different scenarios that can happen when you're solving an oblique triangle. Okay, one side and two angles are known, so when we do this, okay, we're going to use law of sines. So if we have side angle, 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 side angle. So this is going to be on that little note page that you have that has law of sines and law of cosines written down. Alright, and I would make sure that you have all the steps for finding the angles using law of cosines written down as well. Alright, so find cosine of A, cosine of B, cosine of C. Put the algebraic expression down that's there for you. Alright, but if we want, this is just, so if you're given a triangle and you're given the knowns on the left, here's what we're going to, the steps that you would take to want to solve the problem. Assuming we want to use law of sines, law of cosines, that sort of thing. So if we're given the case of side angle angle or angle side angle, so this is from a previous lecture, all right, this is from lecture 1 in this chapter. If we had side angle angle or angle side angle, you're going to use the law of sines. This is from last lecture in case 2, all right? If we have side-side angle, you're going to use the law of sines. And there's the steps you'd go through to do it. In this scenario, these are the new 2 cases that we're doing in this lecture. If we have side angle side, you're going to use law of cosines, and if we have side side side, you're going to use law of cosines. So you should kind of know based on the problem. So this is more for like your test questions and things like that. Well, what am I given? I'm going to step back a slide here. If I'm given side angle angle or angle side angle as my given values, or side side angle, I know I'm going to apply law of sines. If I'm given side angle side or side side side, I know I can apply law of cosines. Okay, it's really just, that's really what it comes down to, is these 4 cases for you to sit there and decide, do I use law of sines here or do I use law of cosines as I'm solving this problem. Alright, so here's what I want you to write down. I'm not going to go through a large derivation of Heron's formula. It's in the notes here. You can step through and watch it and that sort of thing. But we can use Heron's formula to find the area of a triangle, right? Or the semi-perimeter of a triangle. So here's how we use and apply it. So S is called the semi-perimeter of the triangle. Okay? So the semi-perimeter is 1/2 times A plus B plus C. We have to know S because we use S to find the area of the triangle. So S is 1/2 A plus B plus C, so that's always going to be your first step. And then you're going to find the area of the triangle. That's the funky looking A there. That's equal to the square root of S times the quantity of S minus A times the quantity of S minus B times the quantity of S minus C. So kind of like the change in A, change in B, change in C as we go through this. So this is Heron's area formula for a side-side-side triangle. Alright, so we're really going to take half the perimeter. That's what semi means on perimeter. Kind of like a semicircle is half of a circle. A semi-perimeter is half the perimeter. So we're going to take half the perimeter and substitute it in to his formula. Okay? So we can calculate the area here. So the distance as the crow flies, so what that means, if you're not familiar with it, it means at a straight line. So we're assuming, cars, we have to take certain routes and we can't drive straight from city to city because the road curves, bends, things like that. So we apply everything as the crow flies as a straight line. Alright, so from LA to New York is 2,451 miles. From New York to Montreal is 331 miles, and from Montreal to LA is 2427. Okay? What is the area of the triangular region having these 3 cities as vertices? So step 1, find the semi-perimeter. Step 2, substitute it into the equation as we go through there. So the semi-perimeter is going to be 1/2 times 2451 plus 31 plus 2427. So we get a semi-perimeter of 2600 from 4. Okay? Then we substitute into Heron's area formula. Okay? So plug in all, or substitute in all the given values. You're more than capable of that. We know what A is, we know what B is, we know what C is, we know what the semi-perimeter is, and we actually get the area is approximately 401,700 square miles. So there's how we use Heron's formula to find the area of a side-side-side triangle. Alright, so like I said, I'm not going to go through the derivation of Heron's formula. Involves a lot of proofs with the half angle and double angle identity as you go through it. I'm not going to expect you to do any of those proofs on the test. I want you to be able to apply Heron's formula to find the area of a triangle that is a side-side-side triangle, just given those values. Alright guys, that's it for wrapping up the law of cosine. So we should be able to use the 3 versions to find either a side length that's missing or a angle that's missing. Alright, based on the criteria that we laid out, there's 4 different cases, right? So case 1 and 2, we used law of sines. Case 3 and 4, we used law of cosines. And then be able to calculate area using Heron's formula. As usual, email me if you have any questions or need me to work a specific problem out for you. Else, those of you guys in class, we'll go over the examples in class, and I'll answer any homework questions you might have there. Alright guys, have a great day. Talk to you soon.